Okay, this chapter is about the electron transfer. Sometimes we call it oxidation reduction reaction. Okay, um, let's scroll down a little bit. Let's go back and refresh our memory a little bit about oxidation reduction reaction. We learned this at the beginning of the year. Oxidation reduction um, involved transferring of electrons between reducing agent and oxidizing agent. So there are four essential features about this type of reaction. First, one of the reactant has to be oxidized, meaning that it lost the electrons, and the other reactant has to be reduced, meaning that it gains the electron. So the number of electrons that's being transferred from the oxidation reaction and the reduction reaction has to be the same. For example, if the oxidation reaction loses two electrons, the reduction reaction has to gain two electrons. And the oxidizing agent, its oxidation number will decrease, meaning it will be reduced, and the reducing agent will be oxidized. I think it's easier if we look at some examples. Okay, so if you have a reaction between copper, uh, silver ion, and then it produces copper 2 ion and silver solid. Okay, so the easiest way to balance the reaction is called something called the half reaction. Okay, meaning that we're going to split the oxidation reaction and the reduction reaction. So let's take a look at the copper and copper first. So we write it out. Copper become copper 2 ion. You can see that the mass, you have one copper on each side. The mass is balanced, but the charge is not balanced. So what we're doing is that we have to balance the charge also, because this side, the net charge is equal to 0. The net charge over here is 2 positive. So in order to balance the charge, we have to add electrons. Because 2 positive, this side is 0, so we have to add 2 electrons on this side. So that is done. This reaction gives out the electrons. So this is called the oxidation. Okay, oxidation reaction, because it gives out the electrons. So let's take a look at silver. Okay, so silver is going from positive charge, and it becomes a silver metal with no charge. So the mass is balanced, 2 silver on each side, but the charge is not balanced. This side has 2 positive. This side, the net charge is equal to 0. So in order to balance the charge, we need to add 2 electrons. So where does these 2 electrons come from? Essentially, it comes from here. Okay, so you see that now silver, its oxidation number decrease from positive 1 to 0. So we say that this is a reduction reaction. Okay, so if you want to summarize this, you can see that we can add the oxidation reduction together. And what do we have? We can cancel out the electrons, because when you add it up, it cancels each other out. So when you add the oxidation reaction and the reduction reaction together, we will have copper. Okay, I'm not including the phase right now. And then you have 2 silver cation produces copper 2 ion and 2 silver metal. So the reaction is balanced. Okay. Now, one thing I want to point out is that the oxidation and reduction reaction, who is the oxidizing agent, who's the reducing agent? Now, because copper is being oxidized, itself is a reducing agent. So copper is a reducing agent. Okay. And then silver ion here is the oxidizing agent. Okay. So that's for the first one. Let's go down to look at another example. This one is a little bit more complicated. We will again split this into something called a half reaction, meaning we will split the oxidation and reduction reaction apart. So let's take a look at the aluminum first. Okay, aluminum becomes aluminum cation. So the mass is balanced, the charge is not. So we will add 3 electrons on this side so that the charge is balanced. On the left side, oxidate, the total charge is 0. Right side, the total charge is equal to 0. Let's take a look at copper. Okay, copper is 2 positive, and then it becomes copper metal. The mass is balanced, the charge is not. So you have to add 2 electrons over here, so the net charge on the left side is equal to 0, just like on the right side. Now, you can see that the aluminum, this one, because it gives out the electron is on the right side. So we said this is an oxidation reaction. And then now for the copper, because copper gained the electron and the charge of copper decreased from 2 positive to 0. So because this is called the reduction reaction. Okay. So now if you try to add these two equations together, you can see that you can't really directly add it right now because the number of electrons transferred are not the same. You have 3 on the oxidation reaction and you have 2 on the reduction reaction. So to make sure that they're balanced, you have to make sure the number of electrons transfer are equal. You have 3 over here, so you multiply by 2. You have 2 over here, you multiply by 3. So now, if you add it up, you will have 2 aluminum, okay, and then you will have 3 copper, 2 ions. The electrons, you have 6 on this side, 6 on this side. They cancel each other out, and then it produces 2 aluminum ion and 3 copper solid. So there, you can see that the net charge on this side is 6 positive as well as on the right side. So that's another one. Okay. So now, a lot of time that the equation that you will see that is not the balancing equation is not going to be that simple because the reaction usually either is going to be acidic or is this going to be basic. Acidic, how do you know? You have to have H plus, and then basic, how do you know? You have to have hydroxide. Okay. I think this is going to be long, so I'm going to go on to another video. I'm going to stop this video for now. This is going to be part 1, and it will be part 2 in the next video.